sorry, Landon, you missed some stuff, but we're still taking questions from the homework. If you are watching this, which I'm sure you will, if you are watching this and you would like the answers, just send me a message and I will send you a picture of all the answers. All right, number 6. What was I saying? Oh, greatest integer. Oh yeah. So stretch. And this is important because we're going to do a lot of functions, and all these bits, the a, the h, and the k, it works the same no matter what the function is. So the sooner we start to get some of these basic patterns in our head, the easier it's going to be as we continue. Because when we do quadratics, it's the same. When we do exponentials, it's the same. When we do reciprocals, it's the same. It's all the same. So the a, when it's stretched, it's vertically stretched. And so if I have a parabola and it's vertically stretched, it's going to look narrower because it's vertically stretching up to the sky, right? And it's vertically compressing, it's going to look bigger because it's vertically compressing down, right? So it's the same thing with like the absolute value ones. If it's vertically stretched, it looks like that, which looks smaller, but it's stretching up higher. Vertically compressed is like that, so it looks bigger, but it's not. It's actually getting squished down. And so that's a important thing. So this one, greatest integer function. We've got g of x equals -2 greatest integer x.
Why did you do the double bracket?
Because that's how you do greatest integer. Okay. So the parent function for greatest integer thing, which is just f of x, equals greatest integer of x. So the parent function looks like these. It starts here, and from 0 to 1, it's right here, and then it jumps up. Once it gets to 1, it jumps up to the next one, and stair steps his way up. Keeps on going until it gets to 2, and then it jumps up again. If we have the negative part, it's the same idea. Going down, it goes down this way. Okay? That's what a greatest integer function looks like. It keeps on doing that and that and that forever and ever and ever and ever.
What's the one called
Which
that
is
goes like this?
What?
What's the one called that goes like
Absolute value. Okay? This is actually a very common real life type of problem. Anything where you're always rounding up, like you're always getting the highest dollar amount. Like as whenever you put in this amount, you have this dollars, and then once you get this threshold, now you're getting this dollars and this dollars and this dollars, and then when you hit this threshold, you're at this dollars and this dollars and this dollars, right? Or whatever else. It's really common. So that's anything where you round up. So that's what the parent looks like. This is an f of x, right? So this one, it changes the front number, right? It does 2 things. What 2 things do it do?
Negative and.
So, negative and 2. What does the negative do?
Negative switches the way it goes.
The little
direction.
Front number meaning like the way you like the place you start.
Yeah, the one in front of the thing, right in front of the function. So like in front of the absolute value or whatever, in front of the x or in front of the x squared, the one in front of the function. Okay. So it's negative. What does that do to it? It flips it down, yeah? So it's going to take this and flip it over, which this middle one's going to do nothing. That's not going to do anything, right? This one is going to, instead of being here, it's going to be down there. This one, instead of being up here, it's going to be down there, right? What does the 2 do?
Make you do something.
That's what I was just talking about. It's going to vertically stretch it up, which on a greatest integer, it actually kind of looks like what you think. So instead of jumping up by 1, you're going to jump up by 2. You're actually jumping down because it's also negative, right? Making sense?
How do you know it's in the 4th quadrant, not the 3rd quadrant?
Because it starts at 0, 0 in here.
It always
There
says
you go.
0, 0?
The parent does. If we added something or subtracted something, then it would shift the whole thing over.
What's the point at the beginning of the problem if we're only going to use the end of the problem?
What are you talking about?
G, X.
Like, why did I draw this?
No.
No. Okay.
Equinox is just what you read at the beginning.
Okay. Let's graph it. Let's graph our g of x thing. I promise that some of this transformation stuff by the end of the class, if you will screw your brain on, you will get it because the reason I promise that is we're going to see it like 12 times. So, and it's always the same, just with different shapes. So, yeah, this is a shape. This is a shape. This is a shape.
Okay.
This is a shape. This is a shape.
I don't know what I thought you meant.
Okay, I don't either. Okay.
Starting from the same place, like,
Unless there's a translation, but you're going to learn about that soon. Like, am I always starting at the same place? Like, am I starting at 0 or whatever else?
yeah.
Yeah, unless there's a translation, which you're going to learn about soon. Okay.
So
Alright.
what part of the equation tells you that you're going to start? Like at this point.
Okay, so this is future knowledge, but I'll give it to you now to help you out. You ready?
Mm-hmm.
So here's a transformation template for a quadratic function. It looks the same if it's absolute value. It's just this would be absolute value. It looks the same if it's square root, except this would be square root, whatever else. This one is the dilation and reflection. If it's negative, it flips it. If it's greater than 1, it stretches it. If it's a fraction, it compresses it. This one moves it left and right. This one moves it up and down.
What does the square?
That tells you what parent it is.
What does the x do? Nothing?
The x is just that's the independent variable, and we know that because of this. But we will learn all of this, I promise. Just not today. Okay, back to this problem. Eventually we're going to finish this problem. That's fine. We're asking good questions. We're clarifying good things. And I did say the sooner we start to get some of this in our brain, the better. So I'm going to preview it. Now, so he starts at 0. And he goes over to 1. And then he jumps up.
Jumps down
Down, thank you.
by 2.
I wasn't talking to you. Great, smart home devices.
2 from the open side.
2 up and down.
Oh, open. I thought we could go.
This is 1.
Yeah, and then from 1 you go down to.
Over 1.
Yeah. And then we got this guy, and then he goes over here. And then we go down to more.
How do we know that the first one's a closed dot and the second one's an open?
Because that's how the parent looks.
Okay. Can that change?
If it's a different parent. If it was squared, it would be a totally different thing. And then I'm gonna do a couple going the other way, just so we get a nicer graph. Alright, and then up to.
So if, like the one that's -2, if that number was a fraction, how would you do that?
Then it would squish. So it was like it was a half.
Yeah, so
It would,
like
if it was a half, it would instead of going down 2, it would go down a half.
How
Or
do you
up
know-
a half, it was positive.
What if it was like 3/5?
Then it would go up 3/5 each time.
How do you know that it's not like going 2 spaces and something at once? It's always only like 1 space.
Because there's no horizontal stretch. But we won't really even do anything with a horizontal stretch until recount.
So it's always going to be just however many down and over just 1?
For a greatest integer function, yeah. Yeah. Alright. What other
4.
questions, kids?
4.
4.
I
So
honestly-
I'm gonna put 4 back up on the television. Because we have to be able to point to it. Yeah. Smart TV. Is it though? We gotta check back in with, what was his name? Preston? How are you doing, Preston? Are you winning? Or did you let
Maybe it's a different.
Todd win? Oh no, Eric's happy. Does that mean Preston lost? I was rooting for Preston. Only because it was the only name I knew, but you know.
Maybe Preston was one of the announcers or something.
No, he was, well, maybe. I thought he was a team person, but.
It looked like it.
What's happening here?
At the end, throwing at the camera, not big.
Why is my TV not showing up? Oh my gosh. What's happening? Why is only next door's TV showing up?
No idea.
That's some stupid reality TV show. It's like everything that's on nowadays,
It's like a
except for like
romance
soap
show,
operas and
like-
novellas.
High
I think
What'd you
some of
say?
them are siblings. I think it's just like team pairs. I'm pretty sure one of them is just like
Ah,
you
there
and
it
my
is.
sister. Maybe it is. Or
What a freaking moron.
still confusing.
Aha!
There we go.
There we go. Except this isn't even the page we want. I don't even have a picture of the page we want. So here we go. Number quattro.
Broken release my violence.
That was very white
It's kind of
sounding. It's fine. Very green.
What?
Okay.
very
See?
nice.
Alright.
You-
So we're supposed to write the function for one thing, and we're also supposed to say its domain and range, right? Is that what the instructions say?
The distractions of the
Okay.
instruction.
So we got 3 chunks of a piecewise function, right?
Yeah. You want that?
So we need to look at the first chunk. First chunk. What's the slope of the first chunk? Does it look like?
1, 2,
One.
It's clearly negative something, yeah? So
Negative.
it's going down and over, yeah?
negative
No.
2 over 2.
Oh, just kidding.
It's going up.
Is it just
I'm
negative?
gonna punch you in the face. Probably not, but you know.
Sorry, Sean.
Yeah, how about let's see. 2 and 4, 2, yeah. So it's 1, right? Looks like slope of 1.
But it's going over. Oh, yeah. Slope of 1.
It's counting by 2s, right? So it's got a slope of 1,
And then
which means it's gonna, if it continued, what would its y-intercept be?
4.
4. So x plus 4 is the rule. Now, what's the lowest number in that first chunk?
2. Negative.
What's the lowest y number? Where does it quit? Or excuse me, the
Infinity.
x number.
There's no-
So it goes to negative infinity. So x, so it's
20. Is that 2?
No, it's 2, 0.
Okay, I was like, why is this?
it does look confusing. I agree. So this is true if x is less than negative 2, right?
Why do we know it's not less than?
Because the open circle.
Oh. I
I know you knew that.
don't.
For some reason, you ask about that one every time. I don't know. That one doesn't stick in the brain somehow. Okay, so there's that chunk, and then we've got this chunk. What kind of function is that?
The middle one.
It's the middle one. There you go. What is it?
Constant?
It's a constant function. What is y always?
It's
So
always negative 3.
Negative 3. I agree. So it's always negative 3.
Wait, where did we get the x in plus 4 for the first one?
What's good? It's this line. It's got a slope of 1, and if it kept going, it would have y-intercept of 4.
Oh, like where?
Yep. If, and this is between negative 2 and 3, looks like to me. Right? Sound reasonable so far?
Yeah. Question.
I'm trying to look it over. It's kind of probably wouldn't trying to look at the time. I'm listening. You said question. Yes? No? No? Then I can't hear it. It's fine.
She said question mark because she was saying yes
Ah.
question.
I see. Okay. Now, what about
-2 because it goes down
-2, I agree.
two.
Wait, what?
Because it goes down 1, 2 over 1, or if it's easier to see, it goes down
1, 2, 3, 4.
2, 4 over 2, which reduces to 2, because 4 divided by 2 is 2, right?
We're doing
It's-
that thing where it like crosses at the.
Yep. And so, and it's negative, right? So, and what would its y-intercept be if it kept on going?
9.
How?
Positive infinity. Positive
What is
infinity.
this gunk on the TV, and how is it that high? I don't understand.
Positive infinity.
Why did we?
No.
Yeah.
The y-intercept.
Oh, the y-intercept. It's 12.
Yeah.
Where'd you get 12?
I counted. It goes back 1 and then up 2 and then back 1 and then up 2 and then back 1.
Well, it's not counting. These chunks are not 2.
Yeah.
Oh yeah, they are. What are you talking about?
It goes up 1, 2 over 1, up 2 over
12.
Yeah, it's gonna be up there, I think.
It's 12.
Yeah.
It looks like it'd be.
I don't think so.
You agreed with us earlier.
He lied. He's not
We
really
were
great.
like 10 and you were
We
like,
gotta
yeah,
align.
and he
We're
was
getting
like,
the
12.
ruler.
It's
Yeah.
gonna be way up there.
Okay.
Okay? And that's if x is greater than 3.
I think the answers that you showed us with that one, it was 4. It said 4, but it was like really messed up and weird for some reason. That's why I got confused on when it was wrong. But even though I was
What's the
right.
domain of this?
Go.
Positive but negative and positive.
Oh, right. The weird fried egg
And the range?
Yeah.
from
Negative
1 to the
infinity.
other, and then the
To not including 6.
I agree.
Can we do the of the absolute value ones?
Yeah, sure.
22 or no?
Let's do 28.
Let's do 28.
22 is difficult.
22,
The
28.
22 is an absolute value one.
Yeah, I know, but it's still.
Wait, 28 or 22?
I don't know.
28. Because that's the absolute value. 22 is the not. I said 28 because it has lots of extra numbers.
Still makes sense.
22 is not an absolute value.
I said 28.
No.
I said 22, but then realized it wasn't an absolute value.
22 probably should be omitted
Why?
because
It's wet.
it's got a horizontal stretch in it.
Oh, thank goodness.
And you don't really know how to plug stuff into the greatest common integer thing and get something out of it.
Yeah, that's the.
You don't really know how to math that, so that one should probably be omitted.
Thank you, Sean. I love you.
28, on the other hand, you do know how to math.
That's a good question.
You do. You may not know how to put it all together, but you know how to math it.
The time on those.
No, you know it, and you just don't know how to assemble it, which is a different thing.
Or maybe we should just. Is that
I mean, I guess you could have that much gaps, but you have not. But that has not been evidenced in this class so far.
I wonder if she doesn't even know what a number
So,
is.
I'm gonna in order to graph this, I'm gonna tell you two things. Are you ready?
Yeah.
First thing, learning your parents is very helpful. If you can look at this and be like, okay, I know the shape this is gonna make before I do anything else, that's gonna help. So what shape is this gonna make? It's gonna be a V, right? Easy money, yeah? So the next thing is, no matter how ugly this mess gets, you can always graph it. Like I could give you the ugliest thing ever and you could make a picture of it right now. Have you had a question right now? What does that happen? Okay, I haven't said anything yet, but go ahead.
Are absolute values always these?
In this class, yes.
So not always.
Well, when you start throwing other stuff in there too, then sometimes not. Like if it's absolute value of x squared, then it's gonna, something could be
For the
weird.
rest of this class, it's always gonna be.
Yeah, in Algebra 2, we don't mess with combining shapes. We save that for pre-cal. That's the next deal. A lot of pre-cal is the same thing as Algebra 2, but just like smooshed together. But we keep everything separate. We're like, you know, we're like that kid that doesn't like his peas and his carrots a touch, and also doesn't like peas. Okay, so what I was saying is that no matter how ugly this gets, you can graph it. And you can always use one of these to graph it. And that's what I'm going to remind you of right now. Is that we can always just build a table, stick some points, and connect them
But only for the absolute value.
for any function,
Okay,
no
so
matter how ugly it is.
I have a question because I did the table like that and did the math, and for the first one I got it right, but for the rest of them they were all wrong.
Okay, I don't think that's actually a question. Let's continue on in the problem. Let's see if we
I
can figure out
got
why they
it
were
wrong.
wrong.
Why?
Okay.
Why?
So I'm going to plug in -2, -1, 0, 1, 2. Once y'all kind of learn in, I think in the next unit, like that H and K and A thing, you'll be able to more intelligently pick what numbers. Right now, you just kind of stick some on there, and if it doesn't give you a good enough picture, stick some more on there.
So you just put the number like -2 in for x and then do the math.
Yeah.
But that's what I did.
Okay, great.
But
Let's
it's
do
not
it.
right.
Okay, well, let's figure out where you went wrong.
I can't.
Well, oh my gosh. So stubborn.
Okay, takes one to know one there, bud.
Yeah, I was about to say, I thought I was stubborn.
So 2 times 6 plus 6. What? 18. Yeah, I agree. Is that what you said? That was a smug little face. Like, what are you talking about?
16.
And then 2 times -1 minus 4 plus 6. -1 plus 4 is -5. Absolute value is 5, so 2 times 5 plus 6 is 10 plus 6 is 16.
Why is it no longer in the absolute value?
Because I did the absolute value. I did -1 minus 4 is -5, and the absolute value is 5.
That's where I went wrong. I did absolute value stuff.
Okay, great. I told you you'd figure it out.
You did.
You know, little patience goes a long way sometimes.
I have not pitched. Yes.
0 minus 4 is -4. Absolute value is 4. 2 times 4 plus 6 is 8 plus 6, which is 14. Good. Put a 1 in there. We got 2 times 1 minus 4 plus 6. The numbers are getting smaller and smaller. It's exciting. So 2 times 3 plus 6 is 12. 10.
So why didn't it do that thing where it was like 18, 16, 14, 16, 18?
Okay, so it moved. So what I said was, and I still maintain what past me said, that right now y'all don't know how to intelligently pick what numbers, and we kind of picked wrong. So we got to pick some more.
We gotta pick 4 because
It's continuing right now. It's going down, so we probably need some over here, right? So what numbers do we want to try?
27.
Way too big.
No.
Sounds great. 6, 8 sounds all great. Let's put 4 in there. So 2 times absolute value of 4 minus 4 is 0. That's nice.
That's also where I went wrong. I got confused when it wouldn't be all even
Wait, what?
in the four
We
numbers.
skipped 4 numbers, not just 2. Because it's 2, and then it's
Yeah,
6.
that's great. Why not? Is that messing with you a little bit?
So if you see that it is continuing to go down, then you just add some more numbers.
Yep.
Then it's
If
10.
it doesn't look like what you expect it to look like because of the parent, then yes. Oh, look. Here we go.
4.
So we can just assume the next one would be. Oh, so
Let's
we
get
have to
2.
do.
I want my 2s. That's plenty. That's great. Let's graph it.
Yippee.
Yippee skippy. Somebody shoot the dove. Please. Somebody come get her. She's whistling for dinner. Actually, it's, well, I don't know. Why do doves coo in the morning? Because there's no way it's a mating call, because they do it year round, every day, all the time. So
They feel out
that's not how birds work.
because they feel like it.
So
Maybe
what
we
is
like
it like
maybe
it's
we
safe
should
in this
track
morning?
friends.
They're trying to what?
Track friends instead of mates.
That would be a novel experience. You wouldn't understand that.
They say,
I have more friends than she does.
1,
they say it's
2,
safe until they
3,
get caught.
4. Down. 1, 2, 3, 4, 5, 6. We got a dot, and
Wait,
then
what?
these.
What? Where?
These.
What? Wait, pause. Go
I'm
back.
just doing
What are you doing? Oh, what are you doing?
Except I'm not doing that.
I was like,
Just
what?
kidding. How about up here? I don't know why. I don't know why I made that 6 a negative. But I did. 1, 2, 3, 4, 5, 6. Lamio.
Where did we?
Zacchio,
Oh, 6. Okay.
Damio,
I was confused.
Lando. Why?
Why? What?
I'm just taking those points in, kids. That's all I'm doing.
Wait, no, I'm confused.
That's all I did.
It's so simple.
I put the dots, and now I'm connecting the dots.
Look at
Those
that
dots,
shit
these
line,
ones.
he's graphing them.
These ones.
Makes sense.
I started with this one, and then I did a few more on this side, a few on this side. I just stuck the dots on the board, connected them. That's all that I did. This is 4, 6, yeah? Right? Yes? And then 2, 10 is over here somewhere, yeah? And then 6, 10 is over here somewhere. Connect the dots.
That's so good. Yeah, that good.
What?
Nothing.
You got this or not so much? Good. Alright, kids. Go away.
Yes.
Find somebody that loves you.
What if we
Tell them I had to do piecewise functions today. So
Cry
sad.
to them.
tell them we spend actually
Isn't that hard though?
It's
I am
not
so
that
sorry.
I need
hard,
to
but it
redo
is
the homework
confusing.
though, so I can remember it.
I know.
That's
I need.
Got this.